I'll take these three terms as the first three terms. So let A by R, AR be the first three terms of the given GP because it is easier for the simplification. Two numbers are in GP, we know it is given by square root of AB. So therefore, if I am converting this in terms of GP, I know the ratio between these two numbers is same as this. Hello everyone, a warm welcome to one and all. This is Yashati ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the geometric progression as well as the geometric series. So we have learnt the sequence of geometric progression and the last term as well as the sum of its term. So we know that in a sequence of geometric progression, the last term is given by an is equal to a r to the power n minus 1 and the sum Sn is given by a into 1 minus r power n divided by 1 minus r or a into r power n minus 1 divided by r minus 1 depending upon whether r is less than 1 or r is greater than 1. Now let us take few problems. So the first question is, which term of the GP 2832 will lead to the number 131072? So here we need to find out the term number. So that is nth term. So we know that an is equal to a to the power r into n minus 1. So in this series, the very first term is considered as a and the ratio of these two numbers, that is 8 by 2 or 32 by 2 is the common ratio, that is r is equal to 4 here. So now an is given, that is 131072 and the first term is 2, common ratio is 4 to the power n minus 1. So dividing this, we will get 4 to the power n minus 1 is equal to 131072 divided by 2, which is 65536. So here this can be written as 4 to the power 8. Now since here the base is common, we can equate the index. N minus 1 is equal to 8. So we get n is equal to 9. So therefore the ninth term of the series is 131072. Next question. Find the sum of first n terms and the first 5 terms of the geometric series. So let us take an example. A is equal to sum 1 and r is equal to 2 by 3 here. I need to find out the first n term, that is just general term for all the terms in GP and sum of first 5 terms. So now I have taken an example where r is less than 1. So I need to use the formula Sn is equal to a into 1 minus r to the power n divided by 1 minus r. So I have taken the first term as 1. So here I will get 1 minus 2 by 3 whole to the power n 1 minus 2 by 3 here. So if you solve the denominator 1 minus 2 by 3, you will get it as 1 by 3. So this is equal to 1 by 3 and 1 by 3 I can multiply here. So therefore Sn is equal to 3 into 1 minus 2 by 3 whole to the power n. So this is the nth term of the given series. Now the same term should be expressed in the sum of first 5 terms. That means I can take the value of n is equal to 5 here. So therefore S5 is equal to, so I have already got the general formula of sum of series for the given example. So I will take the same formula here, 3 into 1 minus 2 by 3 whole to the power 5. So which is 3 into 1 minus 2 power 5 is 32, 3 power 5 is 243. So now here it becomes 243 minus 32 divided by 243. So here it get cancels. So which is 81 in the denominator and in the numerator it is equal to 211 by 81. So this is the value of the first 5 terms of the given geometric progression. Next, the sum of the first 3 terms of GP is 13 by 12 and their product is minus 1. Find the common ratio and the terms. So here the first 5 terms of a GP. Generally the terms of GP are A, AR square and the last term is AR n minus 1. Now I'll take the previous term of A, which can be written as A by R. So here I'll take these three terms of the first three terms. So let A by R, AR be the first three terms of the given GP, because it is easier for the simplification. So they have given the sum of them is 13 by 12 and their product is -1. So first let us take the sum. They have given A by R plus A plus AR is equal to 13 by 12. So let's take this as equation 1. Second is they have given A by R into A into AR is equal to -1. So take this as equation 2. Solve this. We'll get A cube is equal to -1, which can be written as -1 whole cube. Now the index are same, therefore the value of A can be equal to -1. Now if we substitute A is equal to -1 in the equation, then equation 1 becomes -1 by R plus -1 plus -1 into R is equal to 13 by 12. So taking minus outside or after simplification, so we can write, so -1 minus R square is equal to 13 by 12. Or I can write this as 12R square plus 12R plus 12 and plus 13R is equal to 0. I can write this as 12R square plus 25R plus 12 is equal to 0. So using factorization, so we can write the value of R as 4R plus 3 or 3R plus 4 is equal to 0. So where we will get R is equal to -3 by 4 or R is equal to -4 by 3. Now here we have two different values for R. So therefore if I take A is equal to -1 along with R is equal to -3 by 4. So then GP will be equal to, so here the first term is A by R. So -1 by -4 by 3 becomes 4 by 3. Next is A -1. Next is the product, so which is 3 by 4. If I take A is equal to -1 and R is equal to -4 by 3, so then the GP is A by R -1 by -4 by 3, which becomes 3 by 4, comma -1, comma 4 by 3. So either it will be of the form 4 by 3, comma -1, comma 3 by 4 or 3 by 4, comma -1, comma 4 by 3. Next, find the sum of the sequence 7, 7, 7, 7, 7, 7, 7, 7, 7, 7 up to n terms. So let us take the sum of the sequence as Sn. So this is 7, 77 plus 777 plus 7777 up to n terms. So now to solve this, we'll follow a method now. So observe carefully. So we'll take 7 outside. Then here I'll get 1, 11, 111, 1111 plus etc. up to n terms. So it's common up to n terms. Now I'll multiply by 9 here and I'll divide whole by 9. So 7 by 9, 9, 99, 999 plus 9999. Again 9 multiplies up till n terms. Here 9 can be written as 10 minus 1. 99 can be written as 10 square minus 1. 999 can be written as 10 cube minus 1. Similarly, this is 10 power 4 minus 1 and up to where here? Up to n terms. So now here I will separate all 10 and separate 1. Then 7 by 9 is 10 plus 10 square plus 10 cube until n terms. And taking minus outside, we have 1 plus 1 plus 1 up to n terms. Now this is in terms of geometric progression, because you can observe here 10 square by 10 is 10, 10 cube by 10 square is also 10. There is a common ratio between this sequence. So we can use the formula of GP here. So what is the formula for GP? R is greater than 1 here. So here I can use 7 by 9 into A. What is the first term? 10. R is 10 power n minus 1 divided by 10 minus 1. Next we have minus 1 plus 1 plus 1 plus n times is n. So therefore this is equal to, so 7, here 10 minus 1 is 9. So 7 by 9 into 10 by 9 into 10 power n minus 1 minus n. So this will be the general term to find the summation of the given series. Next one. Find the 20th and the nth term of the GP 5 by 2, 5 by 4, 5 by 8. So we need to find out the 20th and nth term. So the general formula is A r to the power n minus 1. So that is an is equal to a r to the power n minus 1. So the first term A is equal to 5 by 2. R is 5 by 2 divided by 5 by 4. So we'll get the value as 1 by 2. Now R is less than 1 here. So now first let us find out the nth term, because it is easy to find out 20th term later when we find an. So an is equal to, A is 5 by 2, R is 1 by 2 whole to the power n minus 1. So 1 to the power n minus 1 is 1 only. Now then it becomes 5 by 2 into 2 to the power n minus 1. So the power of 2 is 1. 1 minus 1 get cancelled. So it is 5 divided by 2 to the power n. So this is the nth term. Now what will be the 20th term? 20th term is 5 divided by 2 to the power 20. Next question. Find the 12th term of a GP whose 8th term is 192 and common ratio is 2. So we need to find out the 12th term, A12. They have given 8th term, that is A8. A8 can be written as A into R to the power 7. Because the general formula is ARN minus 1. If you want 10, AR power 9. If you want 5, AR power 4. So the power of R decreases by 1. So therefore here it is AR to the power 7. And this is equal to 192. They have given the common ratio is 2. So therefore A into 2 power 7 is equal to 192. So now 192 can be written as 2 power 5 into 6. So 2 power 5 cancels here. So A is equal to 6 divided by 4. We can write this as 3 divided by 2. So the value of A is 3 divided by 2. So we know the common ratio, we know the first term. So let's find A12. So A12 is A r to the power 11, which is equal to 3 by 2 into 2 to the power 11. So 2 cancels here. So it is 3 into 2 power 10. So 3 into 1024, which is equal to 3072. So this is the 12th term. Next one, the 5th, 8th and 11th terms of GP are P, Q and S respectively. Show that Q square is equal to PS. So the 5th term, that is A5. A5 can be written as A r power 4 and this is equal to P. 8th term, A8, this is A r to the power 7 is equal to Q. Next A11, this is A r to the power 10 is equal to S. We need to show that PS is equal to Q square. So let us consider this as equation 1, equation 2, equation 3. Let us multiply 1 and 3. Then here it becomes A square r power 4 into r power 10 is r power 14, which is equal to P into S. So here A r power 7 whole square is equal to PS. So from equation 2, A r 7 is nothing but Q. So therefore we will get Q square is equal to PS. Next question. the fourth term of a GP is square of its second term and the fifth term is minus 3. Determine its seventh term. So the fourth term A4 is equal to square of its second term. Second term is 2, so it is a square of this. Next we have the first term is minus 3. So first term A is equal to minus 3. We need to find out A7. Now A4 is nothing but AR cube. A2 is nothing but AR whole square here. So now here AR cube is equal to A square R square. Now here A cancels, R square, 1R get cancels. We'll get R is equal to A. Now since R is equal to A, R is also equal to minus 3. So now we need to find out A7. A7 is equal to AR to the power 6, which is minus 3 to the power 6. So which is equal to minus 3 whole to the power 7. Next question. Which term of the sequence 2, 2 root 2, 4 is 128? So they have given AN is equal to 128. So now AN is A R to the power n minus 1 is equal to 128. So what is A here? 2. What is R here? 2 root 2 by 2 is root 2. So root 2 to the power n minus 1 is equal to 128. So root 2 whole to the power n minus 1 is equal to 128 by 2 is 64. Now if I convert square root in the index form, I'll get 2 to the power n minus 1 by 2 is equal to 64 can be written as 2 to the power 6. Now since the base are same here, the powers can be equated. So therefore here I'll get n minus 1 by 2 is equal to 6, which implies n minus 1 is equal to 12. Therefore n is equal to 13. So therefore the 13th term of the GP is 128. Next one. For what values of x the numbers minus 2 by 7, comma x, comma minus 7 by 2 are in GP? So when two numbers are in GP, we know it is given by square root of AB. So therefore, if I am converting this in terms of GP, I know the ratio between these two numbers is same as this. So that is x divided by minus 2 by 7 is equal to minus 7 by 2 divided by x. So here this becomes x square 7 by 2 into 2 by 7. So cancels here, x square is equal to 1. So therefore x is equal to plus or minus 1. So the number may be minus 1 or plus 1. The next sum is find the sum of n terms in GP, root 7, root 21, 3 root 7, etc. So here the first term is root 7. So root 21 can also be written as root 7 into 3, which can be written as root 7 into root 3. So similarly, it's a product of a number with root 7. So therefore, here the first term is root 7. The common ratio is second term by first term, which can be root 3. So now root 3 means greater than 1 obviously. Since we are talking about the sum is given by a into r power n minus 1 divided by r minus 1. So it is root 7 into root 3 whole to the power n minus 1 divided by root 3 minus 1. So if we want to rationalize this, then we can multiply by root 3 plus 1 by root 3 plus 1. So here this is root 7 into root 3 plus 1 into root 3 to the power n minus 1 whole divided by, so 3 minus 1 is 2. So this is divided by 2. Next one, evaluate summation from k is equal to 1 to 11, 2 plus 3 per k. So let us expand this by substituting the value of k. First one is 2 plus 3 power 1. Next is 2 plus 3 power square, 2 plus 3 cube until 2 plus 3 power 11. Now let's separate this. 2 plus 2 plus 2 plus up to where? 11 terms. So all these are 11 times repeated. Similarly, this 3 power 1, 3 square up to 3 power 11. Now 11 times 2 is 11 into 2, which is 22. And the second term is, it is in GP. So let's apply the summation of GP here. The first term is 3. Common ratio is also 3. So 3 power n minus 1 divided by 3 minus 1. So which can be written as 2 plus, so 3 power n minus 1 divided by 2. This can be written as 22 plus 3 to the power n plus 1 minus 3 by 2. So this is equal to 22 into 2 is 44. 44 minus 3 is 41 by 2 plus 3 to the power n plus 1. And the n value is, means there are 11 terms. So therefore this is equal to 41 by 2 plus 3 to the power 11 plus 1, which is 3 to the power 12. So this is the final value. So in this session, we have taken a few problems on GP. I'll meet you in the next session. Until then, keep watching, keep learning, and keep exploring. Thank you.